Good afternoon, everyone. My name is Ciel Vaughan and I work with Share Screen Africa, and it's a pleasure to be your host for this afternoon's event. Um, just a few sort of housekeeping rules. Please do keep yourselves muted. You can have your cameras on or off if you'd like, but if you do have quite a distracting background, then please do consider turning it off to avoid any distractions to the speakers. So, today's session is looking at demystifying carbon credits from sequestration to accreditation. Our first speaker today is Dr. Romain Pirard. He is an economist who doesn't just study problems, but also weaponizes the carbon market to solve them. So he's looking at turning invasive trees in South Africa into biochar, clean energy, and even these climate credits we're talking about. So he's got 2 decades spanning working with Greenpeace to working with the World Bank. He mastered rare alchemy, translating thorny ecological challenges into viable financial models. And this evening, he's going to reveal how carbon pricing could flip the script on invasive species and prove that sometimes the best climate action starts with chainsaws and spreadsheets. So thank you very much for that, Roman. And our second speaker today is Jackson Mungoni. Jackson doesn't just engineer solutions, he electrifies them. So he's transformed over 250,000 lives in rural Africa by turning carbon credits into solar lights, and also winning awards for his work. So as a founding voice of Zimbabwe's carbon market, he bridges policy and practice, ensuring that the communities are those who benefit directly from the climate finance whilst also cutting emissions. He's done gold standard projects to designing, championing farmer-centric carbon projects, and these are both scalable and deeply human as well. So welcome to our wonderful speakers today. Thank you so much for giving us your time and expertise. Just before I hand over to our first speaker, Roman, I'm going to run through our key learning outcomes for today. So we want to be able to understand the environmental and economic impacts of invasive alien trees, learn how carbon markets could support value-added industries like biochar, compare eligibility criteria across carbon crediting standards, and finally explore how blending adaptation and mitigation funding could boost land restoration. So thank you very much, Roman. Over to you.
Well, thank you very much, Ciel, for the introduction. And without any further ado, let me share my screen. Good afternoon, everybody, or good morning. And I hope you got some very good insights yesterday when you had presentations about the operations around the issuance of carbon credits and what are the objectives of actually getting carbon credits and using them. So just in a nutshell, I guess you have understood now that carbon credits are actually a way to reward projects that reduce emissions or sequester more carbon after removals from the atmosphere. So it's basically a way to contribute to climate change mitigation. And you've got different kinds of markets, compliance and voluntary. We won't get into these details today because I guess this is something you've already understood from yesterday's conversations. I am a researcher myself, currently hosted by the University of Stellenbosch in South Africa. And as a researcher, obviously, I'm not a practitioner. So compared to the other presenter that will come after me, I just analyze some of these issues and provide recommendations and things like this, but I've never actually designed and implemented a carbon project itself. So I think these are going to be quite complementary presentations, and questions of different kinds can be addressed to any of us. So it also means that the examples I am going to give in this presentation are fictional cases, and they are not actual projects implemented on the ground. And I think you understand better why I'm saying this now. So the case or the situations I am going to present today and try to to explain properly are quite unusual from the perspective of carbon credits. I think you've understood now that usually the projects that get these carbon credits are about changing sources of energy, shifting to renewable energies or changing transportation modes to reduce emissions or even industrial processes, but also a variety of so-called nature-based solutions, which, for instance, could be, sustainable land management, afforestation and reforestation projects to sequester more carbon in the ecosystems. So these situations I'm going to discuss today are very different and very unusual. So I hope it's not going to be too confusing, and I welcome any questions of clarification you may have, because I think it's important for you not to be lost in all of these facts. So it is also going to be about South Africa, but what I'm discussing today is applicable beyond the country, and especially in all of the neighboring countries of Southern Africa, where you have quite similar issues with invasive alien trees. So just in terms of context, invasive alien trees obviously are trees that are not indigenous to the locations where they spread and grow. So, and they're invasive in the sense that they can propagate very fast and without any sort of support by human beings. So it's an issue that has been identified a very long time ago, and we had the first national maps of tree invasions in South Africa published in 2010, and this is the one you can see at the bottom left of the slide. So you see all of these dots in green and red. The colors refer to the density of invasions, because you may have invasions on an hectare of land with just a few trees or a complete cover, depending on the density. That's what we call the density of the invasion. And so you can see that it's usually along the coastline and mostly in the north eastern part of the country, and the provinces of KwaZulu-Natal, Gauteng, and Limpopo, for those who are familiar with South Africa. It goes up to 20 million hectares. So the maps have been updated actually just very recently, and with quite similar figures, yet with some increases actually in invaded areas at the national level. The trees that we're talking about could be usually acacia species, eucalyptus, willows, pine trees, but also prosopis, and many, many others. But these are the ones that are usually prominent in terms of invasions and cause the most problems. On the right side of the slide, so you have these two pictures taken before and after land clearing operations take place, because in practice, as we want to get rid of most of these trees that create lots of problems, land clearing operations are undertaken by a variety of actors, and I'm going back to this a little bit later in the presentation. And so that's what it might look like. Especially, it's a good example because it's very typical, as it shows invasions along a river stream, a water stream, and for that matter, it's a river, as invasions cause most problems when they propagate along water streams because of water use issues and water availability afterwards. So trees, obviously, I mean, everybody hears about the benefits of having trees with large plantation programs and so on and so forth. As a matter of fact, invasive alien trees are trees as well, so they may have the same benefits. So you have to, compare and balance the positive and the negative impacts of them, and not necessarily always focusing on the negative ones. So, but just for you to have a better sense of what we're talking about, the negative impacts of these tree invasions are mostly about fire hazards, and these fire hazards are going to increase over time because of climate change itself and longer drought periods and things like this. Also, in terms of water availability, because they usually use a lot of water. This is a contested issue because it's very case specific and location specific. But in most of the cases, there is consensus, scientific consensus, that they reduce the amount of water that would be available for human consumption or for agricultural uses. And this is usually the main motivation actually to undertake programs of land clearing. Then you have the productivity issue, because when a land is invaded by all of these trees that are not supposed to be there, it's also limited and reduced access to the land for various agricultural activities, and in particular livestock farming. So basically, in some countries, because of all of these invasions, there are lots of pastures lands that cannot be accessed anymore. So it's as much land that is not available anymore to grow cattle. So with lots of economic impacts. And then biodiversity, of course. The picture you have at the bottom left shows the very typical and endemic ecosystem of Western Cape, which is called the fynbos. And this is just an example of these ecosystems with high levels of biodiversity that are threatened by these invasions when the trees encroach on the land and destroy this ecosystem, then they take over. So this is about the negative impacts. Positive impacts, very briefly. Of course, it's a source of fuel wood, for instance, but it could be timber for construction purposes as well. It could be a way to get shade in order to get protected from the sun and the heat, even for tourism purposes. It could be medicinal trees as well, with lots of interest to cure diseases and sickness. And then fire breaks. So just to give you a few examples, but what you need to understand from this is that the negative impacts largely dominate and prevail over the negative ones, so that there is consensus that something has to be done about it. And speaking about what can be done or what's been done about it, as a matter of fact, even though there's been a very, let's say, world famous program actually, in terms of addressing tree invasions in the world, that is called Walking for Water, that was implemented, that it's been implemented in South Africa for about 25 years now. I think it started in 1998, showing the will, the political will to actually address this. But even so, the impacts have been very limited, or at least they've fallen short of what needs to be done to address such high levels of invasion. So remember what I've said before, we have up to 20 million hectares of invasions, and this program could only address, let's say, hundreds of thousands of hectares of invasions, and in many cases without proper follow-up treatments, so that it doesn't solve the problem in the long term, maybe just for a few years. And then the trees come back. So basically, things have been done, but far from what's needed. So then an idea has been floated for a long time, and it's not specific to invasive alien trees. It's actually something that applies to many invasive species of different kinds, including animals around the world. And it's to, taking stock of the lack of resources, of public resources that are made available to address the invasions. Then the idea would be to develop and establish new value chains that would make use of these biomass. Because trees obviously are a big source of biomass, and biomass has a value. And I would say it's got an increasing value over time. For many, many reasons. And here you've got different examples of the products that can be made out of these invasive trees. It could be in the space of energy, with either wood chips and wood pellets and so on and so forth. Charcoal, obviously, as well. But it could be other kinds of products, timber, obviously, but also a biochar, mulch, even feed for animals and things like this. So the idea is, okay, we don't have enough resources to address invasions. At the same time, biomass has a value. What about establishing new value chains that will increase the scale of land clearing operations? Because in order to get access to the biomass, you need to go and clear the land. So that would be a win-win strategy in theory. Obviously, it's also a subject of controversy because people say if you involve private investments and you develop value chains that need the biomass, then there is no incentive to eradicate the trees because there will be a renewed need for the same biomass. It's a debate we can have later, but this is not the core of the presentation, so I'm just touching briefly on it. Also in South Africa, you've got an energy crisis, obviously, so there is more and more need to develop renewable energies. Biochar is also a very important product, kind of the talk of the town. It's emerging very rapidly. People see lots of positive impacts of applying biochar to the soils, but it could also be incorporated to construction material to store the carbon for long periods of time. It's useful for water filtration systems and so on and so forth. So plenty of potential here in theory to involve the private sector and increase the scale of land clearing operations. Yet, this is a beautiful idea on paper, but in practice, very difficult to pursue, especially because even though biomass has a value and invasive trees are, in theory, open access, because you can go and collect the biomass as the trees are not supposed to be there. So it's actually necessary, compulsory by law to get rid of your invasive trees on your land. Even so, it becomes very costly to establish a supply chain to get sufficient volumes and reliable volumes of biomass coming from these invasive trees in order to supply your needs. So if you build a plant, I don't know, to produce biochar, for instance, and you need X amount of wood every day or every week, it's actually difficult to make sure this is going to happen because it's not a tree plantation that you can maintain and you know exactly what's going to be available in terms of volumes. And it's quite costly. So the financial feasibility so far for many of these value chains has been contested. And there is no clear-cut case, I would say, for this. So the idea is to harness carbon markets and to get additional revenues from the sales of carbon credits if they are issued in the framework of these value chains in order to make these investments profitable and financially feasible. Yet, of course, as I said at the very beginning of the presentation, it's unusual because people think about planting trees to sequester carbon and then you get credits, or you avoid deforestation. You conserve a piece of forest and you get credits because you reduced emissions out of the conversion of the forest. Here, it's about cutting down trees and using the biomass and getting carbon credits for it, which is very counterintuitive and wrong at first sight. But worth an examination, as I'm going to explain, and it's actually something that is possible, and I hope you will understand the conditions for it to become possible and feasible. So basically, the question is twofold. One first question is, would these projects or value chains, whatever you want to call them, eligible as carbon projects in order to get carbon credits eventually? So that's obviously the first question and the first condition to meet. And if the answer is yes, and you get carbon credits, then the other question is, would the associated revenues be significant enough in order to be a game changer and help your project to break even and become profitable, so that the investor into a biochar production facility or a bioenergy production facility actually change his decision from no to yes and move forward, because these additional revenues associated with the sales of carbon credits would actually make it profitable. So these are the two questions I'm addressing now. So in terms of eligibility criteria, they are, let's say they depend on the standard. So I don't know if you get it from, I don't know exactly what's been covered in the presentation yesterday, but basically if you want to get carbon credits, you need to have your project registered and verified and monitored by a certain accrediting standard. Could be gold standard, it could be VCS, Vera, it could be Pure Earth. There are many of them around here. So they all have their own approaches and conditions to meet in order to decide and assess whether a given project is or is not eligible. So basically, in our case of using invasive alien trees to produce a diversity of end products, there are three big types of conditions that have to be met and that depend on the crediting standards that are targeted. So the first one is that the biomass you use as feedstock is actually classified as waste biomass. So basically what it means is you, as part of your project, didn't go and cut down the trees in order to get the biomass supplies, but these trees have been cut down for whatever reason, usually because of land restoration purposes, and harvesting operations may have been undertaken and funded by the Walking for Water program at the national level, for instance, and then the biomass lays on the ground, unused, potentially burned subsequently, or just available and subject to a decaying and rotting over time, hence releasing greenhouse gases such as carbon dioxide or methane. So if your biomass qualifies as waste biomass, then you might have an eligible project. That's the first type of condition. Another type of condition looks more at the overall carbon balance. So basically with this condition, you have to meet a number of conditions relative to what happens to the land after your own operations to get access to biomass. So what is the land use after biomass removal operations? Does the land go back to the original ecosystem, and particularly a forest, for instance, which would mean that the carbon is sequestered again. So there is no, the overall carbon balance is either neutral or positive. What you took from the land is going to go back to the land afterwards. So that's a different approach from the waste biomass. It looks more at, it's some sort of a life cycle analysis, or let's call it a carbon balance approach. Then a third type of condition looks specifically at the types of operations that lead to the harvesting and collection of the biomass. Are these operations sustainable? Which in turn refers more to the quality of the operations, the kinds of equipment you use, whether you respect labor rights, and whether you invest into land restoration afterwards. So it's all about the sustainability of how you undertake harvesting and how do you supply biomass to your own factory. So first of all, I want you to understand here that the main point really is that depending on the standards, crediting standards, eligibility is assessed in very different ways and according to very different conditions and criteria, which in itself is quite surprising because they are all supposed to contribute to climate change mitigation, right? So they should all be subject, I would say, to the same rules for eligibility. But we'll come back to this later, and maybe you have questions for clarification about this. So if we take the two concepts of waste biomass or renewable biomass, according to what I've explained in the previous slide, and try to apply to this type of carbon project, which is using biomass from invasive alien trees in order to produce different kinds of end products, you can look at here the situations where a project is or is not eligible. So on the left side of the slide, it's an application of the waste biomass concept, and on the right side of the slide, it's an application of the renewable biomass concept. And you can see that the results are very different in terms of which situations become eligible or not eligible for the two types of approaches. So on the left, the green area shows the situations where your project would be eligible. And you can see that the type of land clearing operations, which is a column in the middle, or the post-removal land use, which is a column on the right, don't matter. Whatever happens about the type of land clearing operations or post-removal land use, it's always in the green area, which means the project will always be eligible. But what makes a difference and what matters, let's say what determines the eligibility, is the driving factor behind land clearing, which is basically whether the biomass qualifies as waste biomass or not. And the only situation that is eligible is when the trees have already been cut down for other reasons than supplying your own factory or your own needs. So you just come after the operations have taken place. These operations are independent from your own investments, but then the biomass is available, you come and collect, and it's fine. Your project is eligible. Now, when you look at the other case on the right, with the application of the renewable biomass concept, you can see that it's almost the opposite. The driving factor behind land clearing doesn't matter because blue areas are the ones that show situations where the project would be eligible. So the driving factor behind land clearing doesn't matter. All situations it has to be sustainable. And what happens after removal, and you want to actually make sure that you return the land to its original condition. So if it was a forest, it has to come back to a forest condition, a forest state. Right, so what you need to understand here is that for a given situation, a given project, depending on the concept that is applied to decide of eligibility, you will end up with a different assessment, eligible or not eligible. So a same project would or would not be eligible depending on the standards that you choose to harness or to work with in order to get carbon credits. You check the time, so you have a bit of time. So what I would like to mention as well is that based on our conversations and with all of these actors, we realized that the very specific case of biomass from invasive alien trees was actively considered by these standards because it's a tricky situation. Once again, let me repeat, invasive alien trees, you want to get rid of them. This is not something you want to keep on your land for all of these negative impacts, because of all of these negative impacts. So there's been a very specific arrangement, I would say, that has been crafted for invasive alien trees as part of these carbon projects. So that's the example of the Puro.Earth crediting standard. that looks a lot at carbon dioxide removals projects, where you sequester carbon and remove it from the atmosphere and sequester it for long-term periods. And you see that the only situation that would not make it eligible is that the operations are not sustainable. The rest doesn't count because of the very specific situation with invasive alien trees. The question you may have is that correct in terms of climate change mitigation? Because when a carbon project is deemed eligible, it means that you can actually prove, in theory, that it has a contribution to climate change mitigation. The fact that it's just dealing about invasive alien trees shouldn't in itself be a guarantee that it's going to have a positive contribution on climate change mitigation. So this is, I think, something we can discuss, and that is maybe a loophole in all of these approaches. So now, remember, we have two questions. One is, would these projects be eligible? That's what I've tried to answer so far. And then the second part of the question is, if it is eligible, then would the revenues associated with the sales of carbon credits be significant enough to change people's decisions, investors' decisions, to develop these new businesses and value chains? In order to assess this, we use carbon projects, and we need these methodologies in order to make the calculations about the amount of reductions involved, and in turn, the revenues that could be generated and distributed to the project proponents. So these three methodologies are first about biochar production. It's a Vera and VCS approved methodology. And then the two other ones are about bioenergy. So one about small-scale thermal with stoves, small stoves. And the last is industrial heating with boilers, so on a bigger scale. Right. So we've applied these three methodologies and calculated the amount of revenues potentially generated for these projects. So on this slide, you see on the three columns, the three different methodologies, or let's call them projects. And on the first line, on the second line, you see the maximum affordable supply cost in terms of how many dollars per ton that corresponds to each of the three types of carbon projects. So basically, if you take the example of biochar, what it means is that you can pay up to $145 per ton for biomass if you want to break even. If you want to have a biochar project that is financially feasible, in other words, that is profitable, right? Same applies to the two other types of methodologies or carbon projects, small-scale thermal and industrial heating, with different values. So now, based on our calculations, we can see what would be the new maximum affordable supply cost that is allowed by the additional revenues from carbon credits, because these three figures for biochar, $145 per ton, means you don't have any specific revenues associated with carbon credits. This is a situation without a carbon project. Now, with a carbon project and the revenues associated with the carbon credits, you should have a higher maximum affordable supply cost because you've got more revenues. So you can afford more costs, obviously. You know, it's on both sides of the equation. So if we take an assumption of a price of $15 per ton of CO2 for carbon credits, you end up with these new values in red. So in the case of biochar, you've got an increase of about $12. So instead of $145, you can now afford up to $157 per ton of biomass to collect biomass from invasive alien trees in your project. On the other end of the slide, in the case of industrial heating systems or industrial heating systems, this value doubles. So from $23 to $45, it's a game changer potentially. Because, $23 per ton is really difficult to get. It's usually more expensive than that. But 45 becomes usually possible. You can usually get supplies of biomass from invasive alien trees for around that cost. So that would potentially be a game changer. Now, another way to look at it is to look at the share of the product value covered by carbon credits. So basically, biochar, for instance, if it sells for $1,000 per ton of biochar, then the revenues associated with carbon credits would amount to about 4% of it, which is very tiny, especially considering that you've got lots of issues with the development and the design and implementation of carbon projects. You've got lots of hidden costs. It's very complicated. I think that's maybe something you got from yesterday's conversations. It's not easy. You don't just have to push a button, fill in a form, and you get the credits. It's a very long process and lots of uncertainties involved. So 4% I would say, is really not worth it. 20% in the case of industrial heating systems is definitely something to consider seriously. It could definitely change calculations by investors. Now, and I don't have so much time, so I won't get into detail about this one, but just for you to understand that biochar is a specific case in terms of carbon credits because they usually qualify as carbon dioxide removals instead of emission reductions. And when they classify as carbon dioxide removals, they usually fetch a much higher value on the market. Let's say up to 150 or even sometimes $200 per ton, compared to $5, $10, $15 per ton for emission reduction projects. So then, don't pay too much attention to the graph, but what it means is that if you can actually sell credits at such a high price, whatever the value of the biochar eventually, your project will be profitable. So that's why you have a lot of interest in many countries, including Southern Africa, for investors into carbon projects, because it's like a new gold mine. And we can discuss whether this is real or not, but that's if you have questions about this. So let me accelerate before asking a few questions about the ideal scenario where you combine funding for adaptation and funding for mitigation. Because what you have to understand from what I've presented before, for a project to be eligible, a project of this kind, I would say, to be eligible, it's not a given. You have to prove that you are not responsible. Most of the time, you have to prove that you are not responsible for the logging of the trees in the first place. And you just come and collect the waste biomass. Because even though I've discussed different types of criteria and approaches to assess eligibility of the projects, in most of the cases, it's about waste biomass. You have to prove that it's not you, the logging of the trees cannot be attributed to your own business. The trees would have been cut regardless. They would have been cut down regardless. And that's very difficult in practice. So, as you may remember as well that I've explained at the very beginning of the presentation that you had lots of positive impacts of clearing the land out of these trees because, they encroach on biodiversity, they in the first place. So ideally, you would have funding for to clearing the land of these trees in the first place. Then the biomass lays on the ground. It's on the sites. You have two possibilities. One is to let the wood on the site to decay or to be burnt. Then you release all of the carbon in the atmosphere, and there is no mitigation benefit, only adaptation benefits. The other situation is you come and collect the biomass, which qualifies as waste biomass, using mitigation-based funding because you get carbon credits for it. Then you produce biochar or you produce bioenergy or other products, and you add mitigation benefits to adaptation benefits. And the situation is just better. So I think, Marith, it would be a good time now to ask the questions with your magic tool.
There we go. So on your screen, you should be seeing the Mentimeter. You can click join if you want to join through Zoom. And I'm also going to share the link to the Mentimeter now if you want to join directly on Mentimeter. So in the chat, I'll be sharing the link. And then, Romain, you just let me know when you want to move to the next slide.
Yeah, so I would suggest that we wait a bit to see the answers to the questions.
Okay, 100%.
And maybe for me to react and maybe follow up on some of these answers to correct them if necessary. And then
Yeah,
we can move.
perfect. Okay. So the first question is, mention an example of positive impact and of negative impact of invasive alien trees in South Africa. So you can just type your answer in and it will appear on the screen, and then we can discuss it. So please, guys, go ahead and get typing.
All right, yeah, so competition with native species, indeed. So basically it's reducing biodiversity because, invasive alien trees tend to be dominant because they can very well adapt to these new environments. This is why they thrive. And so they can prevail and take over from indigenous species, which is really a problem, obviously, for many reasons. And yeah, so thanks for someone mentioned something that I didn't, so which is very good. Obviously, invasive alien trees sequester carbon just as indigenous trees would do. So from a climate change perspective, it's from a climate change mitigation perspective is just as good, except that, and I think it's really something to understand that is very important. You may have a treeless ecosystem, such as, let's say, a grassland. A grassland is a good example. So you have grasslands in, I don't know, KwaZulu-Natal, in many places in Southern Africa, and they're treeless. So people just assume that if you plant a tree on a grassland, there will be more carbon being sequestered. Well, this is not always true, because you may have more carbon that is sequestered above the ground in the stem and the leaves and the branches, but you may have carbon releases from the soils because it changes the dynamics of the soil. And the grassland itself, which was a very healthy ecosystem, might be disturbed and release carbon. Not even talking about the fact that the trees are a given that because you plant trees, the carbon balance will be positive, especially in a treeless ecosystem. Soil stability plus biodiversity decrease. Soil stability, yeah, so I guess it's about land erosion. That's what the person meant. I guess it can be true in some cases, but once again, it cannot be generalized. Some shrubs or grasses can have, actually grasses can have very long roots that are very useful from a land erosion perspective and soil stabilization perspective as well, just as much as trees sometimes. So it's very context dependent as well. Reduction of rangeland, of course, that's true. And it gives me the opportunity to mention something else, I think of interest to all of our participants from Zimbabwe, but also neighboring countries, which is that I've talked about invasive alien trees, but actually you've got a big phenomenon that is as disturbing in Southern African countries, which is invasive indigenous trees. And rangelands, for instance, in Namibia, just to give you an example, can be invaded by indigenous species. So what used to be a savanna with trees scattered on the landscape becomes a very dense kind of a shrub ecosystem that is even impenetrable. So density increased over time, and the land has been invaded, but invaded by its own species. And from a livestock farming perspective, for instance, it's a catastrophe because you don't have access to the grass anymore to let your cattle go and feed.
Romain,
Yes, please, let's move on.
yeah, for the sake of time, I see we've got about
Of
10
course,
minutes
sorry.
left. Okay, so our next question is, why does developing value chains using invasive alien trees merit consideration? So just the same as with the previous one, you can just type your answer and it'll
Yeah,
appear
sorry. So
on.
I think I realized the question was not very clear. So I mean, the reconsideration from the perspective of climate change mitigation. Okay, economic value, yes, indeed. So it's one of the reasons that you make a good use of the biomass. So you provide, jobs and you create value actually when you process the biomass into products that are marketed somewhere. Yeah, biochar, sure. So then it depends on the products eventually. So you have more or less useful products, obviously. So reduces fire intensity, yes. So it actually gives me once again the opportunity to clarify something. When you develop value chains that make use of this biomass, it usually doesn't say anything about what happens after the biomass is harvested. In other words, are there proper land restoration activities undertaken to make sure that the trees don't come back? And that's not always done. And that's one of the problems with Working for Water program, for instance, in South Africa, that in some cases there is, clearing operations and then very little follow-up operations, so that you come back 2 or 3 years later and the land is covered again with all of these young seedlings. And it doesn't really make any difference eventually and in the longer term on the quality of the land, on the restoration of it. Exactly, yeah, a potential to solve more than one problem, indeed. So ideally, it solves the eradication problem or invasion problem, and at the same time creates economic value. So either for local communities or other, investors, depends on the projects, obviously, and how they are designed. Okay, yeah, so there is convergence. So we're good here.
Right, so the next one is, do carbon crediting standards follow a similar approach to assess the eligibility of projects?
That's a straightforward answer. No, indeed. So let me really repeat and clarify this. Standards are free to use their own approaches, criteria, conditions to assess the eligibility. They are independent standards. So they are free to develop their own rules. So as a matter of fact, standards have developed different approaches and different rules for different reasons. And in itself, it shows that not all of these standards are right because they have different rules. So they end up assessing projects differently. So one is right and the other is wrong, at least. So it's a really important point to understand that there is no absolute truth in how standards assess the eligibility and the climate change mitigation contribution of a given project. There is lots of leeway. It's a very complicated matter, and there is as a matter of fact, some of these projects are eligible when they shouldn't, because their contribution can actually be discussed and debated and challenged for climate change and mitigation. All right, maybe we can move on, Mareth.
All right, the next one is, can you mention the two main concepts used by accrediting standards to assess eligibility of biomass-based projects?
So let me clarify, because one answer is removal and reduction. We're talking about something else here. So removal and reduction is not about criteria to assess eligibility. This is more about the type of credits. So basically, you can get carbon credits for different kinds of projects and different kinds of mitigation interventions. And one typical classification is to make the difference between reducing emissions on one side or removing carbon from the atmosphere and storing it on the other side. So one is called emission reductions and the other one is called carbon dioxide removals. This is a reference to the type of carbon credit. This is not about the concepts that are used by crediting standards to assess eligibility of these biomass-based projects. So the other answers got it right. So waste biomass or renewable biomass, that's a possibility. Actually, there are three approaches. It's waste biomass, sustainability of operations, or overall carbon balance. So overall carbon balance, I would say, makes a lot of sense from a climate mitigation perspective, a climate change mitigation perspective, because it looks at more or less a life cycle analysis. So it really accounts for all of the gains and losses in terms of carbon. So it makes a lot of sense. At the same time, waste biomass also makes a lot of sense because it means that you make sure that the business as usual scenario would be that the biomass is burnt or left to decay so that it releases all of the greenhouse gases. That would be the business as usual scenario. And the carbon project scenario is that you actually go and process the biomass into a product that is either used to substitute fossil fuel energy or to store the carbon in the soils for long periods of time with biochar, for instance. So I would say waste biomass is really what makes a lot of sense in the case of biomass-based projects. Okay, maybe we can move on to the next question.
The next one is, what do you think should be an important condition for a project using biomass to be eligible for carbon crediting?
So maybe just for the sake of time, I can just explain a bit on this one, waiting for the answers. We've got additionality, overall carbon balance. Additionality indeed, additionality. So I don't know if everybody now is familiar with the concept of additionality. Just very briefly in a few words. Additionality of a given project means that this project would never have taken place without the carbon credits as a source of additional revenues. So in other words, without the potential to have revenues from carbon credits sales, the investment would never have taken place. And it's extremely important because it demonstrates or it guarantees that what you do is in addition to the business as usual scenario. So it actually has an additional mitigation impact. In other words, it has a mitigation impact because without this investment, the situation would have been worse from a mitigation perspective. So in the case of these projects using biomass from invasive alien trees, but additionality means that without these revenues, nobody would have gone to the field and collected the biomass and processed it into either bioenergy or biochar. So it's really important to assess the integrity of the carbon credits. Involving the community I would say, we could say it's an important condition to meet to make sure that the project is equitable and fair and has benefits locally, but it has nothing to do with its contribution to climate change mitigation. This is a completely different problem or issue. And very important, but nothing to do with climate change mitigation. So let's say it's part of the co-benefits that are expected by many of these projects and that make them more valuable, because they don't only contribute to climate change mitigation, but also to local welfare, improved socio-economic conditions, potentially biodiversity conservation, all of these so-called co-benefits. They are unrelated to mitigation, but they can be necessary conditions to have high value carbon credits that actually solve different problems at once. All right.
Thank you so much. Ciel, back
Great.
to you.
Yeah, thanks, Maret. Thank you very much, Romain. I think that was a really cool little exercise. It was really interesting. And thank you very much to our audience for getting involved and engaged with that as well.